Number 7 is the last one on your study guide. It has a couple of different parts. I want to do a bunch of Riemann sums. I want to interpret them in the context of the problem. Then I want to use a midpoint approximation, put an average rate, and then the last thing I want to do is figure out the way the water is accelerating. So the nice thing about this problem is that each of these interval lengths is 2. So I don't have to go and calculate any weird interval lengths, and my multiplication is actually a lot easier. So I'm just going to kind of talk my way through each of these left-right sums, whatever. So I'll start with the right. The right means I take this, and this, and I multiply them by the corresponding widths and then add them all up. So since all the widths are the same, I can just write it out as 2 times 3 plus 5 plus 6.5 plus 9 plus 7 plus 1. And if I type that in my calculator, I get 63 gallons. Okay, next one, I want to do the right. So instead, I will not do this, and I'll take this guy instead. So I do left. So I'll do these guys. And that gives me 2, which is the width, times, add all them up. 1 plus 2, come on now. 2 plus 3 plus 5 plus 6.5 plus 9 plus 7. That comes out to be 65 gallons. I'm going to do the trapezoid rule next, because in order to do the trap, I just do the average of the two left and rights. So I take 63 plus 65 divided by 2. That clearly gives me 64 gallons. And I'm good with that. The last one I want to do is the midpoint rule. I'm going to get rid of all this work for a moment. Okay, so the midpoint, it says 3 intervals. So that means that I'm going to go from 0 to, oops, need a pen, blank, 0 to 4, and then 4 to 8, and then 8 to 12. So my widths are all 4, and my midpoint is going to be the one in between the 0 and the 4, halfway in between. So the height of that is the number that I take for the height of my rectangle that I'm finding the area of. So I take the 3, I take the 6.5, and I take the 7. So I just do 4 times the sum of those guys. 3 plus 6.5 plus 7. And that comes out to be 66 gallons. If I had a wider interval or more pieces, then I could do a more subparts of my interval, more data. Then I could do a midpoint rule with smaller, with more than just 3. What do I call intervals? All right. So anyway, let's move on to B. B says use the midpoint approximation, which was this guy that we still have written here, to find the average rate at which the water is drained out of the tank. So we talked about this. You just take the integral, the average rate. So it's confusing. This is a rate. So my y value is a rate. So the average y value, which is in this case this rate, is the integral from 0 to 12 of r of t divided by the width. So the width of that interval is 12. So since it says to use the midpoint approximation, I'm going to take that 66. That replaces my whole interval thing. So I just do 66 gallons over 12 minutes. And that gives me 5.5 gallons per minute. I'll go back to A real quickly. It said that you need to explain what that interval is. the context and state the unit. So you should see that you're multiplying time in minutes by gallons per minute when we're doing this integration. So when I do gallons per minute times minutes, I get gallons, and it's the total gallons, total number of gallons of water that is drained from the tank from time equals 0 all the way to 12. I'm going to pause and erase everything. Part C asks us to approximate how the rate is accelerating. What is the flow? At what rate is the flow of water accelerating? So they're asking for gallons per minute squared, because this is kind of like the velocity of the water. So this is the velocity of the water. So and it's in gallons per minute. So it wants the acceleration, which would be gallons per minute squared. So basically, what they're asking for is an approximation of the slope at t equal to 6. So there's a couple ways you could do this. If this was an AP test, they'd have a couple different options for the answer. The easiest way is to just approximate the slope at 6 by looking at the 2 points that are closest to it, so the 8 and the 4. So what I'm going to do is find change in y over change in x, and my x is the 8 to 4, so I do 8 minus 4 to find that slope, and the y are these two. So I do 9 minus 5, and that just gives me 4 over 4, which is 1 gallon per minute squared. That's all.